So we have a trig equation to solve here. They give us cosine x minus 0.75 equals 0. There are at least two ways to solve this graphically, and one of them is the way that they've already handed us. We can graph this left-hand side and find out when it has a value of 0. That's pretty straightforward. Let's see if it works. If you have a calculator, something like this, you can put in as one of your functions cosine x minus 0.75. And let's get a window that'll make some sense here. I'll graph this from 0 to 2 pi. That'll give me an entire period of the cosine function. And we'll leave the y at minus 10 to 10 for now. Okay. You can see a bit of a bump. I'll just shrink the window down to make that a little easier to read. Minus 10 to 10 was a bit big. There we are. So it starts at a maximum, drops right around here. Clearly it's going to equal 0. Then it's below 0 for a long time. It comes back, and about here it's equal to 0 again. You can find those values on a TI calculator using the 0 function. You go to calc, so second calc or second trace, select 0. And what it wants is a left bound and right bound. It wants you to mark off a spot that's to the left of the point you're trying to find and the right of the point you're trying to find. So left bound, I'll just move the little bug. About here is the point we're trying to find, so move until you're clearly to the left of that. Enter. It puts a little triangle mark up above. Now move to the right until you're clearly right of the point you're trying to find. Enter again. These are your left and right bound. The calculator is saying it's going to search in this area and try to find a 0. And if you hit enter one more time when it asks for a guess, it finds 0.723 for the first x-intercept. Then we can do that again for the second one. Second trace, 0. It asks where the left bound is, so move the bug until it's just left of that point. The x-intercept. We could do it anywhere in here. It doesn't matter all that much. And then right bound, move until you're well to the right of that point. Enter. Calculator says, okay, I'm going to search in here. And when it asks for a guess, enter one more time. The other solution is 5.56. Now, we had 0.723 and 5.56. Sorry, they want these to the nearest hundredth, so I should just have 0.72 up here. Those are our first solutions. But they say they want all the solutions on the real line, so this solution is going to happen again after 2 pi, and again after 4 pi, and 6 pi, and so on like that. So the complete solution would be 0.72, and then every integer multiple of 2 pi. And the same thing for 556. That'll happen again every 2 pi after that forever. So that's our first solution, what we call the 0 method of finding a solution. The other method involves modifying the equation a little bit. If you have cosine x minus 0.75 equals 0, you can move this 0.75 and get cosine x equals 0.75. If we graph that, we'll go back here. Now my graphs are just going to be cosine x, that's the left side of the equation, and 0.75 on the right side of the equation. Graph those. I still have the windows from before, so I don't have to do any changes there. And again, we can see there's going to be a crossing point right about there, and a second crossing point over here. To find those, second trace, this time we want to find where the two curves cross, or where they intersect. So intersect is the option you want. There aren't any left or right bounds this time. It just says, is this the first curve, cosine x? Yes, it is. It says, is this the second curve? Yes, it is. These seem like silly questions, but if you had more than two curves on the screen, it becomes important for the calculator to check. And finally, it says guess. This time the guess matters. It's going to find the point closest to your guess typically. So if you want the left point, move your guess over this way. Enter. And there's our 0.72 again. And if you want the other point, second calc, intersect, first curve, yes, second curve, yes, and now move the guess over to the right edge of the screen. That ought to do it. Enter. And there again is our 5.56. And again, the general solutions will be those two numbers plus 2n pi.